We are going to look at a shortcut for determining polynomial functions as being either even, odd, or neither. So as a reminder, an even function is a function when you substitute in for the x a negative value or a positive value that it's opposite. So that negative doesn't mean the number is negative. Remember, x could be negative, so negative x in that case would be positive. But these two values are opposites. So if you put in a 7 and a negative 7, you get the same value. Or if you put in a negative 3 and a 3, you get the same value. So an even function has the same value whether you put in a positive or negative number. An odd function, whatever number you put in for x, the y that you get is the opposite of the one you would get if you put the opposite x in. So that would be an odd function. So to get to the shortcut, what we're going to notice is that whenever you put a negative value into an exponent that's even, you get that value whether you put in the positive or the negative, because this would be negative x times negative x. So the two negatives would give you a positive one. If I put negative x into the fourth, it'd be the same thing. Four negative ones would really turn out to be a positive one. And it would actually even happen for a constant. So if I put in a constant, that would really be the same as x to the 0. So if I were to put in a negative x to the 0, remember anything to the 0 power is 1. So I would still get back that same value. Notice if I use an odd, such as 1 or 3 or 5, well, negative x to the 1, anything to the 1 is itself. So of course I'm getting the opposite. Here putting negative x to the third in would be like a negative x times negative x times negative x, which would be negative 1 times x to the third, and we don't have to really write the 1. And same with 5. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1 would be negative 1 x to the fifth. So because of this, whenever we have a polynomial that has all even exponents, then the polynomial itself will be an even function. Whenever we have a polynomial that has all odd exponents, then we will have an odd polynomial function. If we have a mixture of even and odds, then we will have neither. So let's look at an example. So if I were to have 3x to the fourth minus 2x squared plus 6, notice it doesn't matter whether the coefficients are positive or negative. We're only looking at the exponents. Obviously, if I put a negative x in there, it's even, so the negative's going to disappear, quote unquote. If I put a negative in there, and this is not going to be affected, that's like the x to the 0, so they're all even, so this is an even function. If I have, for example, negative 2x to the fifth plus 3x to the third minus 7x, notice all of the exponents are odd. 5, 3, there's an invisible 1 here, which is odd. So all of them are odd, so this function is odd. Let's get one like this. 2x squared minus 7x plus 3. It's a quadratic function, degree 2. Degree 1. So here's an even, here's an odd. This one, remember, is x to the 0, so that's even. So I have two evens and an odd. I'm mixing the even and odds, so this cannot be either even or odd. So that one is neither. So that's the shortcut for polynomials, that you look at the exponents. If they're all even, then the function's even. If they're all odd, then the function's odd. If there's a mixture of even and odds, then it is neither.